Hello guys, welcome to Unza Tutorials Pharmaceutical Chemistry, which is our test 1 or exam preparation. So let's try to look at this question which came in 2023 test 1. So here they're saying it was question 2b. The overall cell reaction in a Daniell cell is represented by the following reaction equation. So now here, this is the equation that we have there, which is zinc, which is metal or solid, plus copper, which is in aqueous solution, is equal to zinc, which is in aqueous solution, plus this one, which is in solid solution, plus copper. So now, question number 1, it says, write a shorthand representation of a Daniell cell. So here, they want us to write a shorthand representation of a Daniell cell. How can we write? You know that we need to analyze which one is oxidation and which one is reduction. So this topic is under electrochemistry. So now, here the question is we need to write a shorthand representation of a Daniell cell. So how can we write that? So first, let's try to analyze which one is oxidation and which one is reduction. So here, this is the same as zinc is equal to with this one, which is zinc, you see, and this copper is the same as this, like this, which is here, sorry, like that one. So when you look at this reaction which is on top there, you can see that this one, there were loss of electrons. You see, there were loss of electrons, and what is the loss of electrons is what is known as oxidation. So here, the electrons being added at the end of this arrow, that is oxidation. Then here, it's like this. For us to balance the charges, here you can see that here there is a 0 oxidation number. What of here? There is 2 here. For us to balance, you know that electrons are negative, so when you add 2 electrons to this positive 2, you're going to have 0 again, so it will be balanced 0 0 like that. So even here you can't add electrons there, you will add here electrons, so here it will be copper like that one. That's why here you can see that here there is positive 2 plus 2 electrons which are negative, you are going to have 0. Even here there is 0, you have balance. So when the electrons are added at the end of the arrow, that is oxidation. When the electrons are added before the arrow is reduction. So how can we write now the shorthand notation? So this one I was just I wanted just you to understand or to know that zinc was taking place on the anode reaction, which is oxidation. So here, how can I write? So I'm going to write like the way it is here, which is zinc, which is the anode, like that one, you see. So for me to demarcate this portion, which is the solid state, and also which is in aqueous, I'm going to put this one like this, which is a straight line like that one, which is vertical straight line like that one. Then I can put here zinc with it like that one. So this one shows that this one, it is a conductor, and this one, it is in the solution, you get, which is an aqueous solution. Then now this is oxidation part. Now how can I demarcate that this is reduction and oxidation? I'm going to use the same, but it will be doubled now, like this one, vertical lines, which I have. Then I can write, which is this one, copper, which is in the solution in aqueous. So don't forget here, aqueous. Then even here, aqueous, like that one. Then this one is in the solution. Then to demarcate it with the one which is solid, because here they are in a different state. There is an aqueous and also solid state. So here, for me to differentiate those, I can put this a straight vertical line here, so which is copper, then with like this. Sorry, don't forget to put solid there. So here is solid like that one. So that's that. So now, the first problem, we have handled it, which is first question, and it is 2 marks. You can see even for yourself. Then next one. So here, don't forget, zinc, it is on the oxidation part. So most on the oxidation part, it is on the left hand. Then reduction, it is on the right hand, like that one. But they are not necessary. Don't put left and right. I'm just telling you that. Zinc, like the way it is, there is a solid here, which is in the conductor or anode, like. Then here is solution like that. So here you put a demarcation with a straight vertical line to show that here it is in the solid state and this one it is in aqueous. Then when you put two or double the vertical lines, you demarcate the reaction, oxidation part which is on the anode and reduction part on the cathode. That's how you do it like that. Then question number 2, it says, explain the movement of electrons and ions in the cell. 4 marks. Explain the movement of electrons and ions in the cell. How can we explain that? So here, this is the best way you can explain it. So here, you can start with electrons. You can start with electrons. So you can say electrons move. So here, let me just give you this one. Like this one, you can see. Then here, this is I can put that this is an anode. Then here, this is a wire, you see, a conductor. Then here, this is the solution, which is an electrolyte. You can see that's the way it is. So here is A, then this one is B. Then here, there is a cross bridge here, which I can put there to say this is a cross bridge like that one, where the ions will pass like that one. So this is a cross bridge. So now, this is just a simple representation of a Daniell cell. So now I want just to tell you that this one is anode, where oxidation occurs, and this one is cathode, where reduction occurs. So here, where oxidation occurs, the electrons moves from a negative electrode, which is an anode. So here I can show that these electrons are moving here, going where? To the cathode, like that one. So when you're explaining, you tell them to say electrons move from the negative terminal, to which is the anode, to the positive terminal, which is the cathode, across or via the external conductor. Don't forget about that to get that 2 marks, is to tell them to say they are moving from negative electrode, which is anode, to the positive electrode, which is cathode, via the external conductor. So now, when you're talking about, since here the electrons are oxidation takes place in the anode and the electrons are being lost. So when losing of electrons are going to move from this same side to this other side, which is the cathode, or where the reaction is taking place, via what? External conductor or external wire. Then when we're talking about the ions, they move from here, which is the positive terminal. So here, ions moves from the positive terminal, which is the cathode, where reduction takes place, to negative terminal, across what? Which is this one, which is called a short bridge. So that's where the ions moves. Yeah, so, and the short bridge here, the purpose is just to balance the ions, which are here, will move from here until it balances, it becomes the same. So now, I've just showed you using a diagram Now let's try just to put it in there, but I won't write due to the fact that I don't have the space. Again, I've already explained that. So electrons, you should know that moves from anode to cathode via what? External conductor, like that one. Which is, what is the external conductor we have? The wire. Don't forget, that's the one that the electrons were moving from here to there. Then what of so here, what of the ions? So we can say ions, they move from cathode to anode, see, via what? Via a salt bridge. You see, so here you have gotten your 4 marks, but you need to put it in a good English to say electrons moves from the negative electrode, which is anode, to the positive electrode, which is cathode, via the external conductor, which is a wire. Again, you can say ions moves from the reduction half cell reaction, which is what? Which is cathode, to the oxidation half cell reaction, which is anode, via the salt bridge. Then you are done. Because cathode, that is the reduction half cell reaction, and anode is the oxidation half cell reaction, via what? A salt bridge. Then you have gotten 4 marks. Then you can go to question so here I can lab. All right, so here the question is at which electrode does oxidation takes place? So oxidation takes place where? I've already explained that one, so you can just write anode electrode. That's your answer. Then the next question, which is question 4, it says at which electrode does reduction takes place? So here is what? Cathode. Remember to the drawing, the one I drew, we had this. So here, cathode electrode, that's where reduction takes place. Then let's go to the question C. Let's go to question C. So here they're saying, given that the standard reduction potential E, which is for silver and copper ions, are that. We have been given the reactions, then calculate that. So here, let's try to find. Okay, so these are the standard, here the question we are saying, the standard potential, these are for silver and also copper. So now let's try to calculate the E cell. So now here, which is the standard one, let's try to calculate it. So here the formula is very simple. You can just say this is E cell, which is on the cathode, minus E cell, which is on the what? Anode, like that one. So remember, I told you that when the electrons are added at the end, before the arrow, it is reduction. So these are the reduction cell potential. So now how can we put it, the other one, to be anode, or to be an oxidation on the anode part? So it's to look at this, which is this that we have been given, you see. So here, and remember, these are positive, even the other one is positive. So here what you need to do is that you are going to find that is to look at the one which has got least cell reduction cell potential, and when you find it, you're going to reverse the direction, and it will become the oxidation. So now what are you going to do? I'm going just to say this one on the anode is 0.8 minus the one that is on the cathode is sorry, the one which is on the cathode is 0.8, because of this is the reduction, it has got a higher reduction cell potential at this particular time, which have been given these questions. So this now we're going to say 0.34 is a least one at this time, and this will go to the oxidation part, which is Since here it was a positive, it will become a negative, which is 3, 4. Don't change the sign here. So here it will be 0.46 volts, like that. So that is the E cell that we wanted to calculate. So that's that. This one is 0.46 voltage. So that is this. Don't forget this, which is standard E cell. So we've calculated that. Now let's try to go through, or to go to the next question. Gibbs energy. How can we calculate the Gibbs energy? So now the best way, let's try to write a formula. So this is the formula that we are going to use on Gibbs free energy, which is the negative number of moles times the Faraday's constant times the standard E cell, the one that we have just calculated. So here I'm going just to say is equal to number of moles is the one when you balance it. So this is not balanced. You can see this is not balanced. So for us, when we want to balance this one, we need to multiply this other side by 2, so that we can have this to have 2 electrons, even here 2 electrons that will balance in this cell. So what am I going to do? I'm going just to say, when I balance, I will have my 2 there. So here to be negative 2 times what will be my what is the Faraday's constant? So Faraday's constant is 96,485. 96,485 times, then what is my E cell? The one that I'm just from calculating is 0.46 volts, like that one. So now when I calculate, I'm going to have my answer, which is the change in Gibbs free energy is equal to this times negative 2 times 96,485 times 0.46. The answer that I'm going to have is negative 8876.2 joules per mole. Don't forget that. Or you can put it in kilojoules to say change in Gibbs free energy is equal to negative 88.7. You can divide it by 1,000. And so here again there's another 6 here. When you divide it by 1,000, you're going to find that it will be 88.76, like that. So it will be 77, then kilojoules per mole, like that one. So this is the answer that you were supposed to calculate. Let's try to go to the last question. So last question is calculate, which is E cell for the following cell. So now this is not standard E cell. Then we have this, which have been given. So all right, so what are we going to do? So here we have been just given the shorthand representation of this cell, which is silver with this. Then here we have been given even the concentration. Here there is copper. So now what can we do? We have been even given the rate constant together with Faraday's constant. So now here, for us to find the E cell, we are going to say, so this is the last question, which is on that part. So which is E is equal to E standard minus RT over NF in Q, like that one. So this is the formula that we are going to use now. So now, first, what am I going to do? Let me go to this same diagram which I have here. Let me find my Q as well as the N. So here, let me just write the reaction, the same reaction. That have been created. So this is the reaction that we have been given, the one that we wrote at first. This one, this one, which is silver plus this it will give us this and that. So this is the same reaction that we are going to use here, because here silver and what. So what has changed here, we have been given this concentration, and the other one that we are going to use to find the quotient, which is Q. So now what can I do? I'm just going to say Q is equal to it is oxidation to be on top, the concentration, then here reduction. So what am I going to say? Q is equal to, what is my oxidation for copper here, over, so oxidation, you know that we've said is for copper because that's the one that has got the least reduction cell potential. Then here reduction is this one, which is silver, the one that has got higher or the larger cell reduction cell potential. So now here I'm going to say what is the my concentration on copper, which is on the oxidation 0.1. What of the concentration on the reduction, which is for silver, is 1. So here I'm going to say 0.1 molar over 1 molar, like that one. So what am I going to have? My quotient, which is Q, I'll have 0.1, like that one. So quotient will be my 0.1, like that one. So I'm going just to apply the same Q on the formula. So here it will be C, which is E cell. Okay. So here it will be E cell is equal to, what will be what is my E standard E cell or E cell standard? It is the one that I calculated at first, which is 0.46 times, or sorry, not times but negative, which is minus here. Then what is R? R is the rate constant. I have been given this rate constant. Remember, this is rate constant here, which is 8.314. So what am I going to do? So here I'm going just to write the same one, which is 8.314, like that one, the same. Then times temperature. What is the temperature that I've been given? Is 298, like that one. So then over here, don't forget, over, what is my N, number of moles? Remember when we were balancing, I said that this one would be 2. When we were calculating this, which is the Gibbs free energy, we used 2. Even here, that's the one we're going to use. What is my Faraday's constant? Is 96485. Then here in Q is 0.1, like that one. So here E cell is equal to, and I'm going to say, okay, I'm going to say 0.46 minus, then I can calculate to say 8.314 times 298. What answer am I going to have? What answer am I going to have? So here to be 2477.572, like that one. Then here it will be 2 times 96485 is 192970, like that one. Then in 0.1, like that. Don't forget that. Then here we can go, and I'm just going to say 192,970 into this. So here I'm going to rewrite this one, 0.46 minus this into that one. What am I going to have? So is 0.012839, 2839, like that one. Then in 0.1, like that. Then when I reach at that point, I can say 0.46 minus, so I can just say in 0.1 times 0.01 0.012 839. What answer am I going to have? So here it will be a negative, which is 0.02 956 325, like that one. You see? So when I reach there, it's the same as 0.46. Then negative times negative will be positive. The same, I can put 0.02 956 325, like that one. Then what answer am I going to have is so here I can write E cell is equal to 0.4895 6325, then volts, like that one. Then which is, I can round it off, which will be 0.49, like that one. So that is the answer that we wanted to calculate. Thank you so much, guys, for watching this video. Remember to subscribe and share so that we may go at the same pace. This is Brainery, your very own.